Hey, Thomason, this is Mark from the Ceramic team. I wanted to walk you through just a quick demo I put together to help you as you're thinking about building a reputation system for your SwarmZero agents. And in this demo, I'm emulating how you could use OrbisDB to store the raw peer-to-peer trust assertions that agents would be assigning each other. And then EigenTrust using the OpenRank SDK to run compute over those trust assertions and then spit out global trust scores across the network of agents. And then I'll be using your agent UI just to, well, a modified version of it, just to show, how, I guess what those data points would look like as agents are issuing those trust assertions to other agents. And then just to visualize the EigenTrust data as it comes back from our server. So I included a bunch of setup here that I don't think I have to walk through step by step. And what I'll do instead is kind of touch on the things that I think are most important for just gaining an understanding of what we're trying to do here. So what I'll do first is just navigate to the UI that I already have running. And keep in mind, well, while this is loading, I've already went ahead and issued, as if I were these individual agents, issued trust assertions to the other agents. So just to explain what's happening, each agent can create assertions for each of the three other agents across 3 data points. And you mentioned that there's that subset of factors that are only going to be peer-to-peer, so agent to agent. So I've chosen 3 of those: quality, communication, and accuracy. And so for each agent, they should be receiving, across those, for each of those 3 factors, 3 corresponding scores from each of the 3 other agents. And I just have a function that's just assigning random values. So, the levels you see here are going to be a bit all over the place. But the reason this is important is this trustworthiness primitive is what is being used and deconstructed in the Python server that I've set up that will use the EigenTrust SDK to then create a local trust score, a local trust object that the SDK will consume. So if you're running this for the first time and you've followed the setup instructions, you would hit submit. I'm not going to do so because 12 corresponding records already exist that align with the environment ID that I'm using. But if you navigate to the scoring, you can see the corresponding EigenTrust scores as they're being spit out. And so what I'll walk through first is the writing to Orbis part. And so, you see here all of these randomly assigned values from each of the other agents given, a news agent, for example. And so when you hit submit, that would take you through this route. You should hopefully see my VS Code, by the way. And what we're doing here is just separating the the individual trust scores by which agent they're coming from, because what we're going to end up doing is, as if we were, the agents themselves self-authenticating onto the network and then writing that data in the form of an array. And, the individual items within that array will point to other agents because they reflect trust scores across those 3 factors that I mentioned previously. And the reason I think this part is important is we're emulating a pattern here that requires server-side ceramic authentication using did keys and static seeds. And so the idea here is you would presumably have, these private keys assigned to each of the agents, and then they would be able to write and be the controller of their own documents in Ceramic. So what this ends up looking like is the controllers of each of these documents are reflected as did keys, as well as the recipients. I think when I put together the data model, I called it agent ID. And so that's actually a good segue to talk about the data model that we're using. So I've included it just as reference here in definition.json. But like I mentioned before, agent ID, it looks like I had originally defined it as a ceramic stream ID, but the way I'm using it right now is as did keys. And then same with controller, that'll be shown as a did key. And then you see that trustworthiness subarray that consists of scope, reason, and level. And so of course that maps back against what you see in the UI here. Yeah, and just for reference, I've included just an example of how you might use the Orbis SDK to deploy the model, but I've included the model ID here in the as just a default value for this environment variable. So we'll just be using the one that I've already deployed, and then you'll go through the process of assigning each of your agents private seeds, which you can just do by running npm run generate. So I've set up a script that does that for you. So let me start this back up. So that walks through the writing to Orbis part. And so when I don't have it reflected in the UI, but on let's see if I go to agent section. Yeah, on page load, I'm actually running this get all records method, which will actually invoke this select method off of our Orbis class, and then it'll just run raw SQL to look at all records for the corresponding table. And again, that table is the definition that we're using. So all of the rows within that table, it'll give us back. And yeah, so that's just a quick aside on reading. With the Orbis SDK, you can use raw SQL like I'm doing here. You can also use a built-in ORM and GraphQL as well. What I'll do next is actually talk through the EigenTrust part of it. So in the README instructions, you'll see that I walk through how to set up your Python virtual environment and then run it. So we're running this server just so we can access the Python OpenRank SDK. And what we're doing when we're actually calling just the default path is we're actually also running raw SQL using the same environment variable, the table ID, against our endpoint. So getting all of the corresponding rows. And then we're transforming it so it'll end up being arrays that'll be assigned to a key within this LT object, local trust object. And each key will be the factor itself, and then you'll have the corresponding trustworthiness scores from each of the agents. And eventually, when we're spitting that back out, we're doing it in a similar fashion, because one of the things that I wanted to point out here is I've isolated the global scores given whatever factor we're talking about. So And by the way, for this demo, I've only focused on quality, communication, and accuracy. I think I mentioned that before, but I wanted to calculate corresponding global scores just within those realms, but I didn't want to muddy and mix them together to create global scores, which of course you could do. But what this ends up looking like, if we just hit that endpoint, is what you'll see on the screen here. And so each of the recipients of the scores reflected by I as a did key is what's getting read back to the UI that I showed earlier and then shown in these graphs. And that contrasts a bit with some of the other ways you could use the OpenRank SDK. There's this concept of hubs and authorities, but I kind of emulated this example that they show, which is meant to be like peer-to-peer. And so I thought that would be a good fit, given that we're talking about agents scoring each other. Let me think. I think that's pretty much it. The main takeaway here is just showing how the raw scores themselves, the raw assertions from the actors, like whatever actors are participating in that network. So in this case, agents could live on Ceramic using OrbisDB, and then you could have some consumer service that's using the OpenRank SDK to calculate trust scores using the EigenTrust algorithm. And this is it's similar to the pattern that was used for MetaMask snaps. And so that's what I wanted to show here. Would love to hear any feedback or questions you have. And then I will definitely share a link to this repo in the description of wherever I host this video. All right, thanks so much.